Hello, so in this video I'm going to look at trigonometric functions of acute angles. And the first thing that we can start with is looking at the x and y plane. Or in our case, the standard position. So what we'll do is we'll draw like a single ray from the origin. And let's go ahead and just pick a point along here. And then let's go ahead and just drop the altitude so that way you have that it forms a right triangle. Now we'll label this as x, this as y, and this as r, and we could probably indicate that there is a direction from here. So let's call these vertices, let's go ahead and call this one A, and this one is B, and this one is C. These are, let me just change these. Okay. Now, our goal is to basically kind of form the definitions, but this is not really anything new. So what we'll do is we'll just form a projection of our triangle. Okay, now let's go ahead and label them again. So we have our A, we have our B, and we have our C. Now if you want to, you can actually indicate that that is a right triangle. Now, so we do know that these are labeled appropriately, right? So like you have that this segment is x, this segment is y, and this segment is r. Okay, well this means that we can actually form the definition of each trigonometric function with respect to the angle measure A. So you have sine of A, by definition, is y over r. Then you have that cosine of A is going to be x over r. And then tangent, similarly, tangent of A is going to be y over x. Now, we'll go ahead and say that, you have the reciprocal functions, so cosecant is r over y. Secant of A is r over x. And then cotangent of A is x over y. Okay, now the thing about these types of functions is that we can actually just relate them relative to the angle. So what that means is that, for instance, we have that the, let's see, let's write it over here. We have that relative to A, this is the adjacent. Relative to A, this is the opposite. And relative to A, this is what we can just write as the hypotenuse. Okay, so this is where we get into that whole idea of opposite, adjacent, or opposite over hypotenuse and so on. So we can actually say that, this is kind of like saying that you have that's the opposite over the hypotenuse. That's the adjacent. And if you want to use, like adj or whatever works for you, then you can. And then this is going to be the opposite over the adjacent. And then similarly, you're just basically just flipping this and saying that's the hypotenuse over the opposite, and that this is the hypotenuse over the adjacent. And then finally, this is the adjacent over the opposite. Okay, now if you were to kind of just clean this up a little, this is where most students will tend to use the term for sine. They'll just say so, and then they have cosine, which is ca, and then they have tangent, which in this case would be toa. So let me just do this. Right. Okay. So in this case, like what this kind of tells us is that this is kind of like a way that we can kind of memorize the three definitions, because you know that the cosecant is just really the reciprocal. So in that case, we wouldn't necessarily need to create some type of mnemonic device for those reciprocal functions, because as long as we know that they are, then we don't need to do anything for those. So yeah, that's where you get these like little cheesy t-shirts or memes where it says Camp Sokatoa, of which, I mean, in a way, to some, it doesn't even make sense, but for a lot, especially in textbooks, it's always recommended that, that this is one way that you can kind of memorize the definitions. Now, suppose that we had a right triangle in the x and y plane, or we could actually just, consider any triangle. Okay, so let's say that this is our lengths, so 77, 36, and then 85. Now, we'll go ahead and label the angles appropriately, like A, B, and C. Now, let's say that we want to find the trigonometric functions of this right triangle. So you have that if you want to find sine of A, cosine of A, and tangent of A, basically you would just need to go ahead and use the definition. So sine is opposite over hypotenuse, so that's going to be 36 divided by 85. Cosine of A is adjacent over the hypotenuse, so that'll be 77 divided by 85. And then tangent is going to be 36 over 77, because it's opposite over adjacent, or TOA. So you have, actually that's not correct. So we have 36 over 77. Now, if you wanted to find, say for example, the reciprocal functions like cosecant of A, you would just flip it. So you have 85 over 36. Secant of A is 85 over 77, and then cotangent of A is equal to 77 over 36. Now keep in mind that it didn't really matter what the angle measure is, nor did it matter like what B is. Yeah, we do know that A plus B equals to 90, but there was no need to do anything here. Now, say for example one of the sides was missing, you probably could have just used Pythagorean Theorem to reduce it as best as possible, or solve algebraically. Now, one thing that we can do though, say for example, we just look at what is called a cofunction. Now, a cofunction basically looks at this idea of taking your right triangle and for this examples, or for this chapter, you're really just looking at the first quadrant because you want it to be an acute angle. So you have, let's see, so we have A, we have B, and we have C. But then we have the sides A, the sides B, and the side C. Now, of course, the thing that you do know is that a squared plus b squared equals to c squared, but that's not what we want to basically talk about. So, cofunction basically looks like this idea of saying, like, what if we were to find sine of a? What would that be equal to? Well, based on the definition, TOA, or SOHCAHTOA, you have that that's going to be opposite over adjacent, which is a over c. Now, say for example that we want to find cosine of b. Well, for cosine of b, that's going to be the adjacent, so we have a over c. But this is basically telling me that these two are equal. So that means that basically you have that sine of a is equal to cosine of b. Now what that means is that basically that we can have that, that these two, that sine and cosine, are cofunctions of each other. So similarly, if I was to look at tangent, so like if I looked at tangent of A, this would be equal to, let's see, A over B, so that's A over B. But then if you look at cotangent of B, based on the definition, so you have to take the adjacent and the opposite, so it's going to be A over B. So essentially, we have that these two are also equal. So you have that cotangent and tangent are cofunctions of each other. So you have tangent of A is equal to cotangent of B. Now, even if I go through the process of finding sine of B, I'm going to find that the cofunction to that is cosine of A. So that means that you get all these results about the cofunctions relative to the angles. Now, this part is actually pretty important because if I go ahead and I look further into the two angle measures, well, I know that the two angle measures basically say that A plus B is equal to 90 degrees. What does that mean? That means that B is equal to 90 degrees minus A. So what that tells me is that the definition that I wrote down right here, this actually can be rewritten as cosine of 90 minus A. This right here can be also cotangent of 90 minus 90 minus A. Now what that means is that basically you can do the same thing, that B is equal to, or A is equal to B minus, or 90 minus B. So what that does is it gives us this whole list of cofunctions. So like you have that sine of A is equal to cosine of 90 minus A. Then you have that, let's see, we'll just write tangent of A is equal to cotangent of 90 minus A. Furthermore, we can write down that, for example, like cosine of A, I guess we should have wrote that down after sine of A. Cosine of A is equal to 90 minus A. Not 90, but yeah, sine. So we have sine of 90 minus A. Then from there, we know that basically we can do the same thing for the reciprocal functions. So interestingly enough, the cosecant of A It's yeah, let me see. Sine, tangent. Yeah, so we could probably do like this. Secant of A is the same thing as secant of 90 minus A. And then you have that cotangent of A is equal to tangent of 90 minus A. And then finally, you have secant. Secant of A is equal to cosecant. Cosecant of 90 minus A. Okay, so these are the cofunctions. Now there are ways to like show that, for example, that cosecant of A can be easily derived by using sine of A, because you know that cosecant of A is 1 over sine of A, which means that that's equal to 1 over cosine of 90 minus A, but then that gives you secant of 90 minus A. So yeah, you can go through the proofs of each of these if you want to, that just by using the reciprocal definitions. So these are your cofunctions. Okay, now if I wanted to basically find the cofunctions, say for example that you have sine of 75 degrees, and then let's say that we also have tangent of 60 degrees. Well, these actually are pretty simple because all that we need to do is look at our equation right here. So we know that sine of 75 degrees is equal to cosine of 90 minus 75. But that's equal to cosine of 15 degrees. So that means that cosine of 15 degrees is the cofunction to sine of 75 degrees. Now, if we look at tangent of 60, well, it's more or less the same thing because you have that the cofunction to tangent is cotangent. So you have cotangent of 90 minus 60, which is equal to cotangent of 30 degrees. And that's it. Okay, so really all that you're doing is you're just subtracting the angle measure from 90. Now, I would say, for example, that you can try cosecant of 20 degrees. So you know that you have to apply the definition that's up here. Now, it actually doesn't matter if we use sine of b and so on, but you'll just be repeating yourself at that point. As long as you have the original definition, then it's all the same, really. It's just notation, so that's b, that's b, that's b, that's b, and so on. But the definition that you'll be using, or the formula, will be this one. And as mentioned, all that you're doing is you're just subtracting from 90. Now, what if we were to use like this idea of cofunctions, but apply it to like kind of like an algebra problem almost? So some of these do come up like an algebra problem. So for instance, let's say that you have secant of 5 theta plus 14 degrees is equal to its cofunction cosecant equal to 2 theta minus 8 degrees. So the thing that we do know in terms of a right triangle is that the angle measures have to equal to 90 degrees. So what that means is that since these are cofunctions of each other, it's not like we're saying that these go away, but we have to say that basically that 5 theta plus 14 degrees has to be added to 2 theta minus 8 degrees. And what does that equal to? Well, it's equal to 90. So let's see, you have 7 theta plus 6 degrees is equal to 90. But then if you subtract 6 degrees from both sides, this is going to give you 7 theta is equal to 84 degrees. Now, if you divide by 7 on both sides, that's going to tell you that theta is equal to 12. Okay, so in that case, like, you know that theta is equal to 12 degrees. If you wanted to find, for example, like the amount that that this is equal to, well, you know that if you plug in theta back in, that's going to be 60 plus 14, which is 74. And then if you plug in 12 into here, that's going to be 16, because you have 24 minus 8, which is 16. So it's more or less kind of like an algebra problem when you think about it. So if you want to, you can also try the following example. You can try if you take cotangent of theta minus 8 degrees equals to its cofunction tangent, and that's going to be 4 theta plus 13 degrees. Okay, so you know that you're just going to add both of these two and then just set it equal to 90. And mind you that, you know, if this was an exam, then you'd be showing those steps that you took to get 12 versus just writing 12. Well, you know, you just have to be sure that you indicated how'd you find that. Okay, now, what we're going to do in this remaining part of the video is we're going to look at some some special values. Okay, so if we go ahead and consider a equilateral triangle, and I'll try to draw this to my best ability. Let's see. Okay. Now, for purposes, we'll just say that this is an equilateral triangle and that this is 2, this is 2, this is 2. Now, what that means is that basically all the angle measures are 60, 60, and 60. But let's say that we kind of bisect this down the middle. So we're just going to go ahead and draw some line. Now, what ends up happening is that we end up forming a right triangle, or two right triangles. So that means that we can actually break this apart. We draw the right triangle to our best ability, and we're just going to label this appropriately. Now, definitely this is not to scale, so if we were to say that, you know, okay, we bisected it, so that'll be 1, and then that hypotenuse is going to be 2. Now, the angle measure is still going to be 60 over here, so we have 60, but this is going to be 30 degrees. And then you have that this part down over here, we don't actually know what it is, so just use Pythagorean Theorem. So you have that would be 1 squared plus x squared equals to 4. Well, really it's 2 squared, but that's the same thing as 4. So you have 1 plus x squared equals to 4. So x squared equals to 3. So that tells me that x would be equal to root 3. So we'll just put root 3. Okay, so all that we need to do here is just go ahead and indicate that this is a right triangle. And then from there, we can actually start looking at some trigonometric function values. I probably shouldn't have drawn this so long, elongated, but I think it's okay, just as long as you understand that it's not to scale. So we're just drawing like a right triangle. Okay, so if we go ahead and we try to find, for example, okay, so now what we want to do is try to find like sine of 60. So sine of 60 accordingly is opposite over hypotenuse, so that's root 3 over 2. And then we have that cosine of 60 degrees would be 1 over 2, so in that case that's just 1/2. Now tangent of 60 degrees, that's going to be opposite over adjacent, so that's going to be just √3. Okay, so the next thing that we can probably do here is just find, let's see, so we can probably find the reciprocal functions for this. So for instance, you have cosecant of 60 degrees is going to be 2 over √3, but if you rationalize that, that's going to be 2/3 √3. And then we have secant of 60 is going to be just equal to 2. Now cotangent of 60 degrees, that's going to be 1 over √3, but that's the same thing as √3 over 3. So these are the values that you would have for the 60 degrees. Now, what if we wanted to find cosine of 30 though? Okay, so we have that, okay, if we want to find cosine of 30, well, cosine of 30 is the same thing if you take the cofunction. So like for example, we know that the cofunction of that would be sine of 60 degrees. So what that means is that this would have to be equal to √3 over 2. And similarly, sine of 30, well, the cofunction to that is going to be cosine of 60, so that means that it's going to be equal to 1/2. And then tangent of 30, the cofunction to that is cotangent of 60, which means that that's going to be √3 over 3. Now what this means is that basically we can find the reciprocal functions as well. But take for instance this, if you write down secant of 30 degrees, the cofunction to secant is cosecant. So cosecant of 60 is already right there, so that means that that's going to be 2/3 √3. And then you have cosine, not cosine, but cosecant. So cosecant of 30 degrees, well, we just need to look for its cofunction. So secant of 60, which is going to be just 2. And then we have cotangent of 30 degrees, which in this case we just need to look at tangent of 60, which is just √3. So I was able to basically figure out all of the values, all the 12 values, if you want to be specific. So that'll be where we just need to find the first set. Then after that, the rest was just using cofunctions. So in that case, like, that's kind of convenient when we think of it that way. You don't really technically need to memorize these, but I'm going to show you one way that you can. Now, another type of special value that you might deal with is like if we take a right triangle and we label it appropriately like 1, 1, √2. Now this triangle is going to have where there's like a 45-degree angle right there and a 45-degree angle right there. So the next thing that we would just need to do here is, for example, determine the trigonometric functions of sine of 45, cosine of 45, and tangent of 45. So notice that if we do that, that sine of 45 degrees is equal to 1 over √2. But rationalizing that, you get √2 over √2. And the same thing goes for cosine of 45 degrees. You have that based on the definition, it's 1 over √2. So you have that that's going to be 1 over root 2, which is equal to root 2 over 2. And then finally you have tangent of 45 degrees, which is equal to, well, in this case it's just 1 over 1, which is just 1. So that's those values as it corresponds to the right degree triangle, the 45, 45, 90, 45 right triangle. So notice that if we find the cofunction to sine, that's going to be cosine. And then we can find the one for tangent of 45, cotangent of 45. So what that means is that we can actually figure out the reciprocal functions technically. So cosecant of 45. Cosecant of 45 is just going to be root 2 because you have that it's just the hypotenuse over the hypotenuse over the opposite. So that's going to be just root 2. And then you have that secant, it's the same thing. You have that, that's going to be root 2 because you're just taking the reciprocal of this. Now cotangent, that one's easy because you have that that's just going to be equal to 1. Okay. Now the things of which that that we could probably do, for example, is make a chart. Okay, so let's say that we make a chart where we have, for example, like sine of theta, cosine of theta, tangent of theta, and then we have cosecant. Let's do it like that. Yeah, like cosecant theta. And then let's say that we also have, okay, so we'll just put cosecant or secant down over here. So secant theta, and then we'll just put tangent, cotangent theta last. Okay, now our angle measures that we'll basically use for now is 30 degrees, 45 degrees, and then 60 degrees. So basically, the thing of which that we do know about sine of 30, and mind you that we can use those triangles as a guide. So okay, so let's say that, that's 1, that's root 2, not root 2, root 3, and then that's 2. And then we know that that's going to be 60 and 30. And then you have the right triangle, so 1, 1, root 2, and then 45 degrees. Okay, now we'll just write this in as best as possible. So for instance, sine of 30 is going to be 1/2. But if that's the case, then I know cosine of 60 is also 1/2. So we have 1/2. Cosine of 30 is going to be root 3 over 2. So that's going to be root 3 over 2. But that means that I know what sine of 60 is also. It's root 3 over 2. Tangent of 30 is going to be 1 over root 3, but that's also root 3 over 3. Now what that means is that I know cotangent of 60 now, so that's going to be root 3 over 3. Cosecant of 30, well, that's just the reciprocal of sine of 30, which is just going to be hypotenuse over opposite, which is just going to be 2. Now, if that's the case, that means that I know secant of 60, which that's just going to be 2. Finally, not finally, but we have secant of 30. Well, secant of 30 is going to be hypotenuse over adjacent, so that's going to be 2 2/3 root 3. And remember that we found that by taking 2 divided by root 3. Now, what that means is that we know secant of 60, not secant of 60, cosecant of 60. So that means that that's going to be 2/3 root 3. Now, if that's the case, then we can move on to cotangent. So cotangent of 30 is going to be adjacent over opposite, so that's just going to be root 3. What that means that tangent of 60 is also root 3 because they're cofunctions of each other. Now you have that all that you need to do is just find the remaining. So for instance, we know that sine of 45 we just said is root 2 over 2, but if you're doing this by hand or from scratch, you know that it's 1 over root 2, which is the same thing as root 2 over 2. Similarly, you get the same thing for root 2 over 2. Now, tangent we said earlier was just 1 over 1, so that's just 1. Now, since I already know sine of 45, then by that logic, also you could have just said that cosine of 45 is the same thing. And then since you know tangent of 45, that means that you know that cotangent is also just going to be 1. Now, the remaining part of this is that you just want to find cosecant of 45 degrees, which is just hypotenuse over opposite, which means that these two are just going to be root 2 and root 2. Now, I would say that you don't necessarily need to derive this all the time, but it might help that you kind of know what are the special values with relation to the these what I call trig triangles. So like sine of 30, cosecant of 60, and so on. Now you can use a calculator, for example. So like one thing is that you have to make sure that the mode is in degrees, which in my case it's not. So for instance, if I do sine of 30, I know that it's going to give me 1/2, but if I do cosine of 45, it's going to give me an approximation. This is okay if an approximation was allowed, but in the case that you need an exact value, well, it doesn't really help. So in that case, it's good to kind of be able to operate the calculator, but it won't necessarily help for those exact values, like radical 2 over 2. And then if I want to know, for example, like tangent, so like if I do tangent of 60, it's the same thing. If I press enter, it's going to give me an approximation. And then furthermore, like if you want to do like cosecant, like you can take 1 divided by the sine function, and let's say that, for example, that you just did cosecant of 30, so this is how you would have to write it, and then you just hit enter, it's going to be 2. And then you know that if you want to find secant, like for example, like what if you wanted to find secant of 60? Well, by definition, you would just write it like this. But notice that this is cosecant and this is secant, which means that you should expect that they're the same. Why? Because they're cofunctions of each other. So you can actually practice in terms of like, how do you work this out on the calculator, and also like how do you do it by hand. When we get more into like looking at the, say for example, the unit circle, there is a way to memorize the whole unit circle, but we're not actually talking about the unit circle just yet, so that's why I'm not really putting 0 degrees, 90 degrees, 180, 270, and so on, because we're not talking about the we're not talking about the whole unit circle just yet.